Hello, my name is Violeta Georgieva, and today I will talk about unexpected connection clause. Let me introduce myself. I work at VMware. I'm the main Reactor Netty committer. I'm a Netty and Tomcat committer. And also I contribute to Spring Framework and other open source projects. So what's the agenda for today? I will start with common causes for unexpected connection clause. Then I will continue how we can troubleshoot these issues, how we can try to prevent them, and at the end I prepared several demos. So let me start first with timeouts. I'll touch two types of timeouts. First, request and response timeouts. This is the time when the server or the client waits for the request or response to arrive. Let's say that we have a client. The client sends a request, starts a timer, and if the server is not able to provide a response in this time frame, the client will mark the request as timed out and will close the connection. So what kind of examples I can share here? For example, when you have a high latency between the server and the client, this can cause the response or the request to fail to arrive in the time that is specified as a timeout. Or when the server is overloaded, the server might not be able to serve the response in the specified time frame. Idle connection. So when a connection can be considered idle, when there is no connectivity between the client and the server. Typically, servers or network components have configurations for idle timeout, and when they see that the connection is idle, they will close it in order to manage the resources effectively. What happens if the server is overloaded? Sometimes bad server capacity can lead to unexpected connection clause. Let's say that the server receives more connections that he is expected to process simultaneously. Or the server is overloaded with too many resource-intensive tasks. Also the resources, if the server resources like CPU, memory, etc. are exhausted, this may cause a connection clause. In these all situations, instead of complete failure, the server may decide to close the incoming connections. Network errors. For example, network outages. This is a complete loss of the internet connection due to issues with the internet service provider or the network infrastructure. Packet loss. This is a loss in the data transmission. High latency is a delay in the data transmission between the client and the server, and typically this is caused by long distances or network congestion. And what's the network congestion? This is a heavy traffic that affects the data flow and the response times. Also, I can mention here firewall and security configurations. Sometimes the firewall rules are too strict and interpret the connection for a malicious one, which causes a connection clause. Let's say you have a high traffic of requests of a legitimate user. The firewall may decide that this is a potential attack, and this will cause a connection clause. Client-side issues. Sometimes issues with the client-side application also may cause connection clause, and this can be bugs, wrong configuration, invalid requests, misinterpretation of the server response. Let's say that a misconfigured client sends invalid request to the server. As a result, the server will close such connection. Troubleshooting. So proper troubleshooting is really crucial in order to identify the root cause. I think that as a first step, you should identify the peer that closes the connection. Once you identify whether this is the client or the server, then you can proceed with the investigation. In order to do that, you can use tools like TCP dump, Wireshark, etc. And let's say that you identified that the server is the one that closes the connection. One thing that you can check are the server logs. Typically, servers log by default errors or critical events. You have to check also network stability because this is crucial for the communication. You have to check high latency, package loss, network congestion. You have to check for too strict firewall rules. Also, if the connection calls or you think that the connection calls is because of a timeout configuration, you should check on the server and the client the timeout configuration, like, for example, connection pull timeout, request response timeout, idle timeout, etc. And if you identified that the client is the one that closes the connection, then you have to check whether the client is configured properly or whether it sends invalid requests or something else. So how we can prevent that? Let's start with the client side and first with the connection pooling. The connection pool handles established connections to the server so that the client can reuse these connections for many requests. Why this is important? Because the connection pool prevents the overhead of establishing and closing connection for every request. With this, we can improve the performance and also the resource utilization. And for example, if you want to do TLS handshake for every request, right? Also, the client-side application should handle errors and timeouts, and this can be done with applying a retry mechanism for specific errors. Let's continue with the server side. It's really important that you configure the server capacity so you don't, or you prevent a server overload. You have a proper network health and server resources monitoring, which can give you some insights whether you have some potential issues with the server or network. One additional thing is implementing end-to-end tracing. This is really important because you can trace the request from the beginning to the end, from the client to every microservice that will face this request. Configuring connection times has to be done very carefully, and later on I will show you with the demos various things. And last but not least, you have to use reliable and stable network infrastructure. So let me start with demos. And first I want to start with load balancers. Load balancers typically have a mode where they close connections silently. What this means, load balancer will close the connection without notifying neither the client nor the server. When this can happen, when we have idle timeout, so the load balancer will close idle connections. When the connections are too many or they exceed the load balancer capacity. And when, for example, load balancers, they have a health check to backend server. And if the backend server fails to respond to this health check, the load balancer will decide that this is an unhealthy target and will close the connection to the server. So here today, for the demo, I will show you idle timeout on the load balancer. We have a configuration on the load balancer. the client sends a request to the server through the load balancer, and then this connection stays idle. At some point of time, the load balancer will drop this connection. So let me show you one recording. So we have in the cloud one very similar application, just welcome page, but the important thing is that this application is behind a load balancer that has idle timeout for 4 minutes. It also drops the connection silently. Locally, we have Spring Boot application that basically does remote call to the application in the cloud. And we are using connection pool. So now, let's start the application. And let's request the application. The first request is successful, and if we go to the logs, what we have in the logs, a connection pool is created, a new connection is established, and once we receive the response, we return the connection to the connection pool. Now we wait for 4 minutes. And then the second request actually fails with 400 internal server error. What we have in the logs, we have operation timed out. So now I will show you 3 types of solution that you can apply in order to solve this issue. Here you can see that if we ping the application is alive. So what's happening? Why the second request is failing? So first solution, we apply max idle time on the connection pool. How max idle time works on the connection pool? Once we want to acquire a connection from the connection pool, we check whether the connection reaches the max idle time, and if that's true, we close the connection and remove from the pool, and we will try to acquire another connection. In addition to this, we can apply also eviction in background, which means that there will be a job in background that will remove idle connections from the pool. So we apply this here also. So the first request, as before, is successful, and we check the logs, the connection pool is created, the connection is established, etc., etc. So again, we wait for 4 minutes so that the load balancer will try to close the connection. However, because our timeout is lower than the one on the load balancer, the background job already removed this application from the pool, so we don't have any connections in the pool at the moment. And for this second request, we will use a new connection. And because of that, the second request is successful. So what we can say for this solution is working. However, if you don't know the idle configuration of the load balancer, it may happen that you are closing the connections too often, which basically is not what we want to achieve with connection pooling, right? So what's the second solution? The second solution is TCP keep alive on the web client. Here, I will apply a bit aggressive configuration. So the connection will stay idle 30 seconds, and then I will start sending probes to the remote peer every 10 seconds. So let me speed up this again. Yes, I start Wireshark because I want to show you what we have in the Wireshark. The first request, as usual, is successful, in the works, the connection pool is created, the connection is established, etc., etc. So that's not interesting. What we have in Wireshark. In Wireshark, you can see that we send constantly probes to the remote peer, and remote peer answers. So basically, with these probes, we keep the connection alive. And this is really, really important. Let's see what's happening with the second request now. So we are performing the second request. The second request is successful, but the interesting part is in the logs. So in the logs, you can see that basically we are using the same connection from the first request, which basically this is why we want a connection pool, right? We want to reuse the connection as much as possible. So what I can say for this solution is also working for us. And this is something that we want. We want to reuse the connections as much as possible. However, again, if you don't know the idle connection on the load balancer, it may happen that you send too often probes to the remote peer, which might be not okay. So let's see now the third solution. Again, we apply TCP keep alive on the web client, but this time with a bit different configuration. This time we will wait 6 minutes for the connection to be idle, and then we will start to send probes. Again, we want to see what's happening in Wireshark. And again, the first request, as you can expect, is successful. That's not so interesting. Let's see now what will happen in the Wireshark. In the Wireshark, you can see that, so we waited 4 minutes. The load balancer closed the connection. Then on the second minute, we started to send probes. We are sending probes, but the remote peer is not replying. So the connection is dead. There is nobody there. We send this 8 times because this is our configuration. And after the 8th time, we just close the connection and remove it from the pool. This is really important. So with this solution, we are trying to understand as soon as possible that the connection is closed so that we can remove it from the connection pool. And now, if we perform a second request, the second request is successful, but you can see that the pool is empty. The pool is empty, and we establish a new connection for the second request. So this solution is also working for us. But the point for this solution is a bit different in comparison with the previous two, because here we just want to know as soon as possible that the connection is closed. So this is for this demo. Let me continue with the rest of the demos. For the rest of the demos, I will use 2 Spring Boot applications. I call them front-end and back-end. Front-end is listening on 8080 and performs remote calls. The back-end is listening on 7070. So the first one, we have a server that has a request timeout. The client sends a request to the server. There is a network latency. The server is not able to receive the request on time and just closes the connection. So let me go to the IDE and show you what I have. This is the front end. I perform a remote call, but here I intentionally delay a bit the request because I want to simulate a network latency. what I have on the backend server. On the backend server, I have request timeout 2 seconds. And the control list standard just equals the incoming data. Let me start the applications. And I also, as I said, it's always helpful to know which peer closes the connection, so I will start also Wireshark. Okay. And now I will be able to request the application. So what I have, 500 internal server error. If I go to the front-end application, I can see that I have prematurely closed during response. And let's see what's happening in Wireshark. As you can see here, 70. Do you remember this is the backend application? So basically the backend application closes the connection. How we can troubleshoot this? Fortunately for me, I enabled Spring observability. So I have here trace ID. So I can trace the request from the front-end application to the back-end application. And if I go to the server, I can find my logs, and in the logs I can see that I have a request timeout. So what I wanted to show you with this demo is that implementing end-to-end tracing can help you identify the root cause of the problem. Let me continue with the next demo. The next demo is rate limit on the server. So on the server I have rate limit. The client sends many requests to the server, and because the rate limit was reached, some of the connections will be closed. Let's see now what will happen. Let me close all and close all and go to the rate limit on the server. Nothing special in the front end, just remote call. The intrinsic part is in the back end. On the back end, I have some simple rate limit that says, okay, once you reach 5 active connections, just start dropping everything. And the controller is again just echo the incoming data. Let me start the applications. Let me start Wireshark. And now I'm ready to send some load. And as you can see, 5 requests are okay, but 1 failed. So if we go to the front end, what we have here is connection prematurely closed. And what we have in Wireshark is that basically, again, the backend, see here 70. Again, the backend closes the connection. So we need to try to see what's happening on the backend server. And if we go on the backend, fortunately for us, the backend logs with error that the rate limit was exceeded. So, as a summary, what I wanted to show you with this demo is that sometimes, checking the server logs, you may identify the root cause. Let's continue with the next demo. The next demo is response timeout on the client. So we have a configuration for the response time on the client. We sent a request, but unfortunately the server is overloaded. So the client waits, and at some point just closes the connection. And let me go again to the IDE, close. So what we have on the front end, the controller is just remote call, but here I specify response timeout 1 second. And on the back end, the controller again equals the incoming data, but this time I intentionally delay a bit the things because I want to simulate server overload. Let me start this. Let me start this. And let's again prepare Wireshark. If I request the application, again I have 500 internal server error. And what's happening in the logs? I see that I have read timeout exception. Let's verify with Wireshark that really the client is the one that closes the connection because of the response timeout. Here you can see that this is my client. Let me go again back. I don't have it here. Typically, if I enable more logs, you will be able to see the IP of the client and the port, and you will correlate with the things in the Wireshark. But this is what the client sends feed to the server. So how we can handle this situation? We can check whether we have, for example, network latency, server overload, or something like this, because it's evident that just the response didn't arrive on time. And that's the last demo. So what I can say for summary, for sure there is no 100% prevention for unexpected connection calls. You cannot expect that. But applying proactive monitoring and proper configuration for the network, server, and the client, you can at least reduce all these issues. Also, in addition to this, you may think about applying various strategies for solution resilience. So that's all from me. Now, if you have questions, you can ask me. There is a mic if you want. I don't know. Okay. Yes. Because they just don't have a message. They use, this exception is a constant that they just send, and you cannot expect that in the constant you have something specific, right? Yes. Okay. Mm-hmm. Yes.
And you configured your connection pool to start.
Not the connection. If it's the third one,
The keep alive.
yeah, it's not the connection pool, but the keep alive on the web client. Okay.
Okay, so the keep alive on the second connection starts sending the keep alive
Probes. Yes. Mm-hmm.
after 6 minutes.
Mm-hmm.
If from the 5th minute the request is made, it's going to fail.
Yes, it's going to fail. The point is that if you don't apply anything, this connection for the connection pool is alive. So such connections, they are broken connections, but they stay in the connection pool because The connection pool relies heavily on the remote peer to send FIN or RST in order to be able to remove such connections from the pool. And if the remote peer never sends such signals, such broken connections will stay in the pool forever.
So what I'm trying to just infer is that there is no getting away from getting in touch with the people maintaining the load balancer to find out the timeouts. Would it make sense to make that assumption that the client and the proxy need to be coordinated regarding the idle timeouts?
Yeah, I always say that when you want to make remote calls, basically you have to know very well how your servers are configured, how the network components between the client and the server are configured, because knowing this information, you will be able to configure the client better. Of course, you can always provide some idle timeout or some probes on the client, but as I said, this might not be optimal if you don't know the real configuration on the network component or the server. And if I can continue here, the TCP keep alive probes help when you have a load balancer like this. But for example, if you have idle timeout on the server, this is another topic. So because typically the idle time on the server is applied when there is no HTTP request. So just sending probes is not enough for the server. This connection will again be idle until you send a real health check, for example. Yes? Yeah, you can see that, yeah, this is just, are you there? I'm there, but that's all. Yes, it is TCP keep alive, not HTTP, right? I don't think I can answer that. Yeah, sorry.
You don't specify connection
Lifetime.
Yeah.
Yes, at least. All of these things, I'm using the default HTTP client, right? It is Reactor Native. But you can apply with the rest of the HTTP clients. Reactor Native has various properties. Give me a second. Here, what you need is actually max lifetime, right?
Yeah, we don't set it as default.
We don't have any default.
No, but so what would max lifetime be?
Yeah.
Okay.
Yes.
Stable
Yeah, the connection will be there forever if you want to use it. Sometimes, if you want to move the load from one server to another, then it is good to have this max life, because at some point, yeah, yes, because yeah, we will remove such connection from the pool at some time, even though the connection can be reused. Okay, do we have other questions? Okay.
Just want to follow up from this question. So, is there default EMS caching the results, or is there a configuration?
Yeah, there is. This is another thing on the client. You can do something like this resolver, and in the resolver, you can specify lifetime for the DNS cache. Yeah, by default we use NETI implementation for the DNS resolution, so it's not the default from the job. it's not the Java, because the resolver provided by the Java is blocking. Of course, now with the virtual threads, this might not be a problem, but till now we didn't want to use a blocking resolver. So we are using by default the netty resolver, it's not blocking. Other questions? Okay, then thank you very much. This was the last session, and really, really thank you.